This is the photon injection system. Now we've rigged this so we can safely show you this. If you turn this on outside of the vacuum state, it can explode in your face. So please be very cautious, follow directions at all times. You're dealing with a very explosive gas. The photon injection system can start a fire. It's extremely hot, it's extremely powerful. Be very careful. Very simply put, it's just a 55-watt xenon light bulb placed inside the vacuum system. It's very critical that you have a vacuum. You cannot use this on an atmospheric type pressure cell. If you do, you'll have an extremely large explosion. Explosion is impossible inside a vacuum pressure fuel cell. Even if this light bulb breaks and ignites the gas, our system is in a vacuum, much like a light bulb itself. It cannot explode. It'll just make a small noise, thunk, and it's over. Nothing more. Now if you do this without the vacuum, or if you forget and you leave this thing on, it'll explode when you shut off your engine shortly after when the gas is built up. So please, please be extremely careful. If you don't listen to how this is made, you're going to be injured. You're going to have a fire. So you're just going to have to be extremely cautious. The energy that comes off of this light is very dangerous. It has ultraviolet light. It has all kinds of things that make it dangerous to you. So let's be very careful at all times. If that plastic pipe gets anywhere near that light bulb, you're going to have a meltdown and you're going to have a fire. Now this light bulb runs on about 14 volts DC, and it is imperative that you not run it below 12.3 volts. If your fuel cell, lighting system, and so on cannot handle the load and maintain 12.3 volts DC, you're going to have to upgrade your electrical system on your vehicle. So that's our threshold. 14 volts, 12.3, awesome. So notice the distance between this light bulb and this plastic tube. The light bulb itself is several inches below the tube, and the tube is way on the other side. If I put this tube anywhere near this bulb, even in the vacuum state, the excited energy will melt that tube. We could have a pressure buildup, we could have an explosion. Notice on this that I've used a metal wire connector. It's very important that you do this right. And these plastic hoses here, also part of the system. Don't go rigging metal in here. If we decide to convert this to metal, we'll explain why. But right now, use plastic and use our sealing putty, which is poster putty. It's very important that you use an alligator clip just like we show here. Don't connect it any other way. The alligator clip acts like a safety. And see the tin foil? It's not covering the bottom. It's only on the middle of the jar. If you do it any other way, you'll have a fire. Now here the line comes into our hydrogen-oxygen fuel cell dryer through our paramagnetic oxygen system. This system is not for anyone else's fuel cell but the original vacuum pressure fuel cell. Do not combine our technology with others. It just simply is a bad idea. You see this dryer? Looks great, right? Wrong. This dryer actually resulted in a major fire. The tube was way down in the chamber. Big mistake. We found out later that it would seal off slowly and eventually clog, producing an implosion. So don't do it like this. If you decide to wrap this fuel cell and you put tinfoil on the bottom, you also have a fire. Why? Because the light is reflected from the bottom to the top of the lid, just like a car headlight. Let's face it, it's a car headlight. So, no tinfoil on the bottom. This right here will melt the tubes and produce possibly an explosion if you're not careful. So, if you can obey all these rules and consider what we're doing is extremely dangerous and risky, and you've just got to be careful and watch what you're doing. The sides of this tinfoil will protect our paint and body from the emissions of light. It's extremely hot. So anything anywhere near that light bulb is going to get very hot. So you must protect the surfaces with tinfoil. The light can go through the jar and melt your wiring. So that'll protect your wiring if you'll wrap it thickly on the outside. Notice I've soldered the alligator clip on here, and it acts as a heat sink for this light bulb right here. You really shouldn't touch the bulb, which I did. Now we use these cups to make our gas, and that makes it very special. We have a self-destructing anode. That's right, this cup self-destructs and actually turns into gases and things in our fuel cell. Now we've enlarged our clips, you'll notice. Other videos on this website very thoroughly explain how to make this cup system. It's snapped together, lasts a long time, and it destroys 2 cups which are used as anodes. That's positive. They dissolve just like this. So if you're interested in building this cell element and building this fuel cell, you really have to use these cups, which you can find more than likely at a Wally store or something. They're just stainless steel, non-magnetic condiment cups. This stack right here, 1, 2, 3, 4, 5 cups. Other videos, we've used more, we've used less. It really doesn't matter how many cups you use. Simple is better. The larger clips, they last a lot longer than the other ones shown in our other videos. So I very highly recommend that you upgrade your clips to these large type right here. You will notice there's some coils at the top of those clips. Those are inductors. They also give us